Hello and welcome with something new, something interesting, something again. I'm here with a new topic today. So I thought that I must start something that is very much important from your point of view, from my viewers' point of view. That is, of course, that is purely organic chemistry. It has nothing to do with any other subject. As I am a professor in chemistries, especially in organic chemistry, so definitely I will jump back to my own subject again and again. So I'm Professor Dr.Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. And today, before jumping into the topic today, the topic of the day is inductive effect. So before going into inductive effect, I must let you know, and something else, that is electromeric effect. Now, what is an electronic effect? What is electronic effect? Well, because it is also something, as the name implies, it has something to do with you can say it is related to the concepts of inductive effect. So what is simply this electronic effect? Let's discuss that. So electronic effect is something that simply, it is very interesting, aspect. It is something that forms in a chemical reaction, especially due to the movement or migration of electrons on a molecule. Okay, so now this again electronic effect, it has again been divided into 4 different effects. That is, number 1, inductive effect, and then resonance effect, then of course mesomeric effect and electromeric effect, and then of course finally the hyperconjugation. But today we are only focused on the inductive effect. So let's start inductive effect. What is inductive effect? So let's discuss that first. So now, before jumping to simply inductive effect, I would like you to know, first of all, my viewers to know, what is bond polarization. What is bond polarization, or simply what is polarization that is created between the 2 bonds, right? The atoms that are joined together by a covalent bond. So what is bond polarization? Of course, it has something to do with the electronegativities of the 2 atoms that are joined together by a covalent bond, right? So now what happens if the 2 atoms that are bonded by a simple covalent bond, and both of the atoms, they have the same electronegativities, as for example a carbon to carbon bond, both have the same electronegativities. So the electrons that are forming that sigma bond would be shared equally between the 2 atoms, whereas so there would be no polarity. Both will be having the same electronegativity. Keep that thing in mind. Same. Both the carbon or the length of carbon chains all would have the same electronegativity, right? So no polarity will be there. No polarization, right? So now what happens? Then the question arises, it becomes interesting, when, of course, one of the 2 atoms is more electronegative than the other one, right? Okay, so now what happens? As you know, if I take an example of, a poor man's marriage and a marriage that is happening at a rich man's house, what is the difference between? Now you are invited in both the marriages. Now how you are going to select on the same day? Of course, you are going to, most of us, we think about that, then let's go to that one where there would be better environment, better people, better friends, and great atmosphere, and of course the food which we always jumps onto, the food, right? The attack on the food in the marriages I'm talking about. So where is our what is our direction? Our direction is towards that marriage that is of going on in a rich man's house, not the poor ones, because of the poor ones we know that no, we are not going to get what we are looking for. So most of us, we do that. We prefer to choose the marriage that is, or the function that is better from the first one, or the location that is better than the first one. Fine. So so we jump towards that marriage. We jump towards that function. We are attracted to those people, and we are just show up there as they are the most important people in our lives, and we don't visit the other marriage. The same thing is happening here. If you have the 2 atoms, one is more electronegative and the other is not electronegative, or less electronegative, what will happen? That the bonding electrons between the 2 atoms will jump towards the atom that is more electronegative. Now, what is electronegativity? This is again a question. The power of an atom to attract shared pair of electrons towards itself is called electronegativity. So now what happens that when, of course, that bond is simply it is shared between the two atoms that have difference in electronegativities. You can take an example of carbon-oxygen bond. I will show you on the board, but first of all, I thought that I must convey to you. You can take an example of carbon-oxygen bond, right? And you can take an example of carbon-fluorine bond. Both are, having the more electronegative. One atom is more electronegative and the other one is less electronegative. As we all know, carbon is less electronegative compared to fluorine, and of course oxygen is more electronegative than carbon. So now what happens with that? When they pull the electronegative atom, the richer one, the powerful one, will attract the shared pair of electrons from the poor one, the carbon atom, who's very poor, who cannot come up to their expectations. So what happens that when that electronegative atom, it will snatch away, it will pull away the electrons from the less electronegative atom. What will happen to that richer atom? It will gain a negative charge over it, right? It will have a negative charge over it, and whereas a partial negative charge, you can call it, or a negative charge over it. Whereas the atom that has lost the electrons, that has nothing now with it, it will be having a partial positive charge over it. A positivity will be created over that atom that has been left empty, that has no electrons anymore. Electrons are snatched away. If it's a bond between, I'm just talking about the two atoms, a carbon oxygen or a carbon fluorine bond. Now if there is a length of a chain of carbon atoms, if you increase the chain, right, if there is 3 carbon atoms, now that also, if it will also have an effect on inductive effect on it. So I thought that I must share first with you people what is the basic concept behind this inductive effect. What happens? It always happens when one of the atom connected by covalent bond to any other atom is more electronegative and the other one is less electronegative, and of course it will snatch away the electrons from the poor one, the carbons, okay, and of course the one that snatches away the electrons will be having a negative charge as it is more electronegative, and the one that is left, that is empty, that has nothing now, will be having a partial positive charge over it. Keep these things in your mind. These can be asked from you at any time, at anywhere, in any subject, related to chemistry. This is simply called bond polarization. How polarization occurs. Polarization is simply this, that it becomes polarized, right? So let's start our topic today. Okay, so let's discuss. We were discussing inductive effect. This is our today's topic, simply called inductive effect. Now, let's discuss something interesting first. Let's discuss ethane molecule. CH3 bonded to CH3. Now, simply, what I was explaining you right now was about this bond. This one that is shared between these two carbon atoms. Now, as you know, as I've just mentioned it to you, that both the carbons, when they are sharing a single sigma bond, the electron cloud between them is shared equally between these two atoms, right? So now what is happening here, as both have the same electronegativities, both have what? Same electronegativity. Negativity. So now what will happen, that they will share this bond that is forming between these two carbon atoms equally. This would be shared equally between these two carbon atoms, right? As they have the same electronegativity. So now what is electronegativity? As I've just explained it to you, it's an what? Now, first the question arises, I was talking about this electronegativity. So now, ability of, what is electronegativity? What is this term? You must have some idea. It is simply ability of an atom to attract shared pair of electrons towards itself is called electronegativity. Ability or the power of an atom to attract shared pair, to snatch the shared pair of electrons towards itself, it's called electronegativity. So this is the simplest definition of electronegativity. And before jumping into inductive effect, you must know these very basic terms. This is a very basic term which you should know, and most of the students, they forgot, so that's why I have explained that again. So according to this definition, the atom that has the greater electronegativity will snatch an electron pair from the adjacent less electronegative atom. Now here in our case, both the carbon atoms have the same electronegativity, so there is no competition of snatching one another's electrons. The electrons would be shared equally. But if we have, as this carbon to carbon bond, this is also something to note, is not a polar bond. Not a polar bond. Now, what is a polar bond? I think you must all know what is a polar bond. So carbon to carbon bond is not a polar bond, as both carbons have the same electronegative values, right? So keep these things, small, very basic things in your mind before jumping into this very interesting and very important topic of organic chemistry, which is called inductive effect. Whereas if we have a carbon fluorine bond, now here the question arises, fluorine is the most electronegative atom, most electronegative, right? So now what will happen, that of course it will snatch, or it will pull all the bonding electrons or the pair of electrons towards itself. The movement of electrons would be like this, right? So what would that result into? This is what I'm writing, what I just spoke. I'm writing about all that. This fluorine will be having a partial negative charge, and this would be having a partial positive charge, as the electrons were snatched away from it. And here you can see the polarization is clearly seen, right? This is simply, you can see this is simply, you can see a polarization, as it's it's a polar bond formed between these two, carbon and fluorine. So now it's also a bond called a covalent bond, and here there is an unequal, you can simply say unequal distribution of electrons forming the electrons, right? Forming the bond. Or one can say that the electrons enjoy staying on one side of the bond. What will happen? That electrons, they enjoy, the electrons, these are the electrons, they enjoy, they are happy staying where? Staying at one side of the atom, that is towards the fluorine atom, right? So they are happy over there. They are being pulled away by a more powerful atom. This is the less powerful atom, right? So this is more electronegative. So what will happen? This results in a molecule to produce a dipole moment. What will happen? A dipole moment will be produced. Dipole moment. Dipole moment will be produced. And what is dipole moment? That refers to one side to be partial positive and other to be partial negative. Then one side to be partial positive and one side to be partial negative. This is called a dipole moment, right? A dipole means dipolar. So it becomes, one side becomes negative, one side becomes positive. So this is dipole moment. So it refers to, of course, one side to be partial positive and the other partial negative. Now let's discuss another example of compound called propyl fluoride. Here let's discuss this propyl fluoride molecule. Here simply you can see a fluoride molecule, a fluoride atom attached to this propyl group, right? Now, as I've mentioned, that this is fluoride atom is the most electronegative atom. Well, what this is going to do, as being more electronegative, will pull the electrons of carbon number. Now, okay, now I'll first number the carbons. This is carbon number 1. This is carbon number 2, and this is carbon number 3. Right. So now what will happen, that F being more electronegative, this F, it being more electronegative, will snatch. So what will it do? Will snatch or pull the electrons of carbon number 1. This is carbon number 1. It will snatch the electrons that are shared between this F and CH2. It will snatch the electrons from it. And what will happen? It will snatch the electrons. Right? The electrons will start moving towards fluoride ion, right? And what will result? And of course, it will not only it will have, the pulling effect on carbon number 1, but on 2 also and the 3 also. But as the chain goes a bit longer, the effect gets lesser. But the first of all, what will happen that, now as it's more electronegative, it will pull the electrons of carbon number 1, right? The carbon number 1's electrons will be pulled, and carbon number 2 and carbon number 3, so on. But due to carbon number 1, that is this carbon being nearest to this fluorine, it's being nearest, I will write with a different color, nearest to F, it's nearest to F. Now what will happen? Nearest to it is, as this carbon number 1 is nearest to this fluorine, will be affected the most, right? And what will happen? It will have a partial positive charge over it. A partial positive charge over it, right? And the fluoride ion, it will be having a partial negative charge over it, right? Whereas the carbon number 2 and carbon number 3, they are also being affected the same way. They also are facing the same pulling effect, but with a less strength, with a lesser less pulling. But carbon number 1 being the nearest to the most electronegative atom will suffer the most, will have the partial positive charge, whereas again the same pulling will be done between carbon number 1 and 2, and resulting that it will also have a partial positive charges and 2 partial positive charges, and the third, same thing goes on with the third one, and this carbon will acquire partial positive charges, 3 partial positive charges. Now it is simply that carbon number 1 being nearer to F than carbon number 2 and 3, it will have the greater partial charge, and carbon number 2 will have a smaller partial positive charge, and of course partial 3 will have the even lesser, but the overall effect will be on the molecule. Same thing I will explain again, that of course here carbon number 1, that is this one, because of its partial positive charge, will try to attract or snatch the bonding electrons of carbon number 2, that is this one, and carbon number 1, both, right? So now what will happen, that with the result, the carbon number 2, that is this one, will also have a partial positive charges, right? And that will also do the same with carbon number 3, and carbon 3 will also have the partial 3 positive charges, right? Now the carbon having the first partial positive charge, that is this one's effect, as we get far from this most electronegative atom will have the most electronegative effect on carbon. It will have the most electronegative effect, whereas the rest of the carbons, they will be having a lesser effect, but overall charge will remain on the molecule. That should be kept in mind. Now the inductive effect is further, that is inductive effect is further divided into 2 main types or forms, you can say. That is first of all is the I effect. And what is this I effect? I effect is simply called electron withdrawing effect. It is simply called electron withdrawing effect. This is simply called electron withdrawing effect, this I effect, right? So these are all electron. I will now going to show you an example of a series which you should know, which would be helpful, an example, so that you will come to know that how it goes on. So let's do that. These are all what I'm going to write. These are all electron withdrawing groups. Okay, so let's start. I should start with a new color. Okay, so first, number one is F, CH2, COO. Okay, now here this is F, right? As you know that fluorine is the most electronegative atom. Okay, now I'll write down the next number. Number 2, chlorine, CH2, COO. Okay, then of course number 3, bromine, CH2, COO negative. And of course number 4 is iodine, that is being the less less electronegative as compared to the other forms. So here in our case, if I just rotate the camera so that you can see, in our case here, fluorine. Now keep this thing in your mind that these are all electron withdrawing groups, right? But according to this, what will happen, that this fluorine being the most electronegative will be assigned number 1, right? This chlorine next, this would be assigned number 2. The third one in electronegativity is bromine, so it will be assigned number 3, and iodine the most less, so it will be having the 4th number. So now what will be having to this now reaction, according to this example, the more would be the I effect, more stable would be the molecule. What? More I effect, more stable the molecule is. Stable the molecule. So here that means what that refers to. That means 1, then 2, then 3, and then 4. F would be the most stable, right? That is the 4th one. That is the here F would be the most stable. This one, most stable. You just need to memorize a series to understand, or you can say for some examples to understand negative inductive effect on the stability, a negative inductive effect on the stability of the molecule. So that would be helpful to memorize, the stability order, because questions can become to you, it may come to you that what just explain the stability order of the compounds, different examples with different. So let's see. Minus I effect, right? So what compounds could be in it? Let's see that. It's positive. It has F, and F. Okay. And plus again with, of course, R and R and R. Okay, and then again N plus H, and H. And then comes the nitro group, NO2, right? And then comes the this group, cyano group, and then comes this aldehyde group. Okay, so now there's a point to remember. Okay, and this is okay. Let me complete the order first, and then you have another CO. This is a series which you need to remember. Okay, when you are, because these are all compounds. Here in our example here, you can simply see this is the series which you are supposed to memorize for your exams. It can be asked from you, right? So now here, there you have to note down that these three, that is this one, and this one, they have, the most these are the most electronegative, right, among all the other of the you can say molecules, right? This is the one that is, these three are the most of the electronegative, and rest have less I effect. And so these would be having the most of the I effect and are most electronegative, whereas the rest of them, these one, they have the less, these all have the less I effect, and now here one more important thing is that hydrogen has zero I effect. This hydrogen has a zero I effect, zero I effect. Okay, due to what? So now you do need to memorize these series, and this will help you out in this series is very important, and it will help you out in solving many questions regarding the stability order, or you can say negative effect on stability. So just try to memorize this stability order of this, because these are all very important, and these can be asked to you from and these are all extremely important, and you need to remember them just because of their electronegativities. Now these are the +1 effect. Now let's discuss +1 effect. Now these are electron donating simply species. What are +1 effect compounds? These are electron donating species. They all come under the category of +1 effects, and this effect is produced in any molecule due to its ability to donate electrons. Now when the molecule is able to donate the electron, it comes under the category of +1 series, that is this one, right? Okay, so now let's see the series. Now this is the series. In the order would be like this. This would be the order. You can simply see here the order: CH2, then NH2, then of course this oxygen, and then C double bond O. So this is the order which you are supposed to remember always and memorize. And now let's move on to this. Here you can simply see that the most common ones are these. These are the most common ones, whereas there are primary, secondary, and tertiaries also, which and you can see according to their their level. You can see the stability of the primary, secondary, and tertiary. You can see here the primary carbons, the secondary, and the tertiary ones, and of course afterwards the methyl groups. The N ones are the methyl groups. So I think that today's lecture would benefit you, as this is also one of the very important topics of your that are included in your chemistry, and that are included in your organic chemistry students, and all series of topics are related to your syllabus, and they can come to you, they can come in your exams, they can come to you in your MCQs, or in your there is a possibility, because this is one of the very important topics of organic chemistry, and when I was a student, I was very much fond of this subject called inductive effect. So today I have explained you what is inductive effect, what is the other eye effects, the negative effects, and the negative eye effect, and the positive eye effect, and I've explained with you the number of examples also, and I hope that you have understood what is polarization, what is electronegativity, and what is a polarized bond, and what simply things and different examples of eye effect. I've explained you the order also, which are the most electron withdrawing ones and the less electron withdrawing ones. So I hope you like this video. Thank you very much. Let's meet again with something new and more interesting and exciting.